Welcome to Google Cloud Drawing Board, where we doodle our way through the cloud. Today's topic, what is Cloud CDN? This video is divided into chapters. Watch the full video or skip ahead to any section of your choice. Whatever your app or website is, chances are that your users are distributed across different locations and are not necessarily close to where your servers are. This means the requests travel across the public internet through long distances, leading to inconsistent and frustrating user experience. That's where Cloud CDN comes in. Cloud CDN is a content delivery network that accelerates your web and video content delivery by using Google's Global Edge network to bring content as close to the user as possible. As a result, the latency, cost, and load on your backend servers is reduced, making it easier to scale to millions of users. Let's consider an app to understand how this works. When a user makes a request to your website or app, the request is routed to the closest Google Edge node. We have over 120 of these for fast and reliable traffic flow. Then to the global HTTPS load balancer to the backend or the origin. From there, with Cloud CDN enabled, we'll serve the content directly from cache. Cache is nothing but a group of servers that store and manage cacheable content so that future requests for that content can be served faster. The cached content is a copy of cacheable content that is stored on your origin servers, typically including web assets like JavaScript, CSS, images, and videos. Cloud CDN can automatically cache this content with just a single checkbox using the recommended cache modes to cache all static content. If you need more control, you can direct Cloud CDN by setting HTTP headers on your responses. And you can also force all content to be cached. Just note that this ignores the private, no store, or no cache directives in cache control response headers. When the request is received by Cloud CDN, it looks for the cached content using the cache key, which is typically the URI, but you can customize this cache key to remove protocol, hosts, or query strings. For the user's request, if a cached response is found in Cloud CDN cache, the response is retrieved from cache and sent to the user. This is called a cache hit. When a cache hit occurs, Cloud CDN looks up the content by its cache key and responds directly to the user, shortening the round-trip time and saving the origin server from having to process the request. The first time that a piece of content is requested, the Cloud CDN can't fulfill the request from the cache because it doesn't have it there. This is called a cache miss. When a cache miss occurs, the Cloud CDN might attempt to get the content from the nearby cache. If the nearby cache has the content, it sends it to the first cache by using cache-to-cache fill. Otherwise, it just sends the request to the origin server. The maximum lifetime of the object in cache is defined by the TTLs, or time to live values, set by the cache directives from each HTTP response or cache mode. When the TTL has expired, the content is evicted from cache. Now, how do you use Cloud CDN? You can set up Cloud CDN through gcloud command line interface, Cloud Console, or the APIs. Since Cloud CDN leverages Google Cloud Global External HTTPS load balancers to provide routing, health checking, and Anycast support, it can be enabled by easily checking a box while setting up the backends or the origins. Cloud CDN makes it even easier to serve web and media content using Google Cloud Storage. You just upload your content to a bucket, set up load balancer, and enable caching. And if you are like many of our customers, you probably have services that are on-prem or in other clouds. To enable these hybrid architectures, Cloud CDN and HTTPS load balancing also support external backends. Let's get into the underlying details now. Global Anycast IPs provide single IP for global reach. It allows Google Cloud to route users to the nearest edge cache automatically and avoid relying on the DNS propagation delays that can impact availability. It also supports HTTP2 end-to-end and QUIC protocol from client to cache. QUIC is a multiplexed stream transport over UDP, which reduces latency, making it ideal for lossy mobile networks. That brings me to security. Data is encrypted at rest and in transit from Google Cloud load balancing to backends supporting an end-to-end encrypted experience. You can programmatically sign URLs and cookies to limit video segment access to authorized users only. The signature is validated at the CDN edge, and the request that should not get through is blocked right there. On a broader level, you can enable SSL for free using Google Managed Certs. Now, to summarize, use Cloud CDN to improve performance and reduce serving costs for regularly accessed content by automatically caching static content with a click of a button.